Hello and welcome to the Chapter 3 from the KNX Advanced course. It was about flags. Great. My name is Amir and I hope you enjoy it. First of all, what is flag? Each group object has 5 to 6 communication flags. These flags control the communication possibilities of an object with the bus. Okay, in fact, with flags we can define the behavior of the group objects. Okay, we can say this group object can be the group object for actuator, sensor, or as a status or similars. Okay, can be changed the value of it, or if the value of this group object is changed, it should be sent on a bus, and similars. Okay, so whenever you hear about the flags, it means it defines the behavior of the group object for you. Okay, then the next important things is for most of the time, more than 95%, 99%, we never change the flags. Okay, because for professional manufacturer in KNX who release the product from the manufacturer, they already set the flag for us. Okay, so we don't need to change it. We only study it to understand the group objects. But sometimes in manual of the devices are mentioned to change the flag in specific circumstances, or if you want to, for example, configure the new devices with old devices, maybe you need to change the flags. Okay, so keep this in mind. It's not a regular job to change the flags in KNX. Okay, as I said, everything is already provided by the manufacturers, but the flag setting can take place in building view, device view, group address view, topology view, and yeah, that's it. So in this view in ETS, you can go through it and click on the group object and change the flag. Here, for example, now we are in ETS 6. We open the project. Great. So we go to the device menu, for example. Okay. Here, for example, I choose the weather module, and this is a group object. Okay, from this one, you can select the group object, and then you can see the flag of this group object is shown here, CRWTU. Here we can go to the properties and change the flag. Okay, we can select it and then download it to make sure that the new changes are applied to the devices. Okay, so in this way you can change the flag in ETS. Okay, great. So let's go to the next slide. If you want to change the several flags, you can select the several group objects, and from right hand side in properties setting you change the flag. It is possible. Great. So it was the introduction of the flag. Now we want to go deep into each flag and study it. The first one and the most important one for any operation in KNX is communication flag. We call it C. The communication flag is the master switch for communication and is set by default at all group objects. If this flag is not set, the object cannot send or receive telegrams. Okay, this is a main switch, like the main switch. So for whole of the group objects for devices in KNX, these communication flags are on. Look at this KNX virtual, we have it. For weather module, all the C flags are on. For blind actuator, all the C flags are on. For clicks, all of them are on. Great. So the C flag is already on for whole of the group objects. But can you change it? Yes. Okay. In rare configurations, it can be necessary to delete the communication flag. If this is the case, it is highlighted in the application description of the manufacturers. So I already told you, in manual sometimes it is mentioned. So if you want to kill the group objects in KNX, okay, if you want to, for example, keep these group objects in KNX, you only should select it and switch off the C flag and download it. Okay, so never ever these group objects working in KNX. But if some telegrams or packet of data is going through it, we have the acknowledgement. As the book mentioned, the book said, if this object is linked to a group address, an acknowledgement is also sent when communication flag has been deleted. What it means if you switch off the communication flags, okay, and then send or receive data to these group objects in a group address, already the acknowledgement of the receiver is sent to the bus. So in KNX, the sender does not send the telegram again and again and again for 3 times, okay? Because it's already acknowledged. It means although the C flag is off and although these group objects is not working anymore, but the acknowledgement is going on a bus. Yes. So by default, we never touch the C flag, but if you want to kill these group objects, you should switch it off. Yes. Good. Let's continue. Okay. The next one is write flag. So what is a write flag? So first of all, the communication flag of the group object should be on. The next flag is write flag. So what it means? It means if the write flag for any group objects is on, so in a group address, when the new value is coming, the group object change its own value to the new value. It is allowed, okay? But if the write flag is off, so it won't work. In KNX, for all actuators, switch on-off actuators, dimmer actuators, fan coil actuators, heating actuators, and similars, always the C flag and W flag is on. So when the group object of the actuators is placed in a group address, the new value is coming from the sensor or controller, and the current status of the actuators are changed to the new value because the write flag is on. Okay, so let's go to ETS. You can see here for blind actuator, the group object for move, as you see, for example, channel 1, the C flag and W flag is on. Great. Yeah. So the C flag and W flag for move is on because the move of the shutter is responsive to the output of the sensor or controller, and also for stop, and also for position 1 byte. It's height position of the shutter. Okay. If I change, if I go, for example, to the status LED of the push button, I can see the write flag is also is on here because for a status LED of the sensors like the keypad, okay, the new value is coming from the actuators, and it should be right on the LED group objects to change the status of the LED. Okay, great. So according to the book, what said, the typical application of the right flag is an actuator can only be switched via the group telegrams if the right flag is set as its switch object, or an LED on a push button can only react to group telegrams if the right flag is set at its LED object. Great. The next flag is T flag, transmit. What it means? It means if the T flag is on, of course, in addition to the C flag, then the group object always sends the new value on a bus. Okay, for most of the time, for sensors, the T flag is on. So in sensors, the device is in a field level in BMS. Okay, it collects the data from the physical layer. For example, you push the push button, or the motion sensor detects the motion in a room. It collects the data, and because the T flag is on, the new value is released on a bus, sent on a bus, because the T flag is on. Okay, so whenever the T flag and communication flag is on, it means that group objects provide you the sensor function. So as the book said, for example, the object value can be changed by push button action, a change in the temperature, or recipient of a group telegram. The transmit flag is set for sensor by default, and in most cases also for a status object of actuator. Why a status object for actuator? Because we want the actuator to sense its value, the latest value, if something changed. Okay, for example, you switch off the lights from the monitoring from your mobile phone, and the keypad in a room should be updated, the LED in keypad. So the T flag of the actuator status should be on to send the data on a bus. Great, so let's go to ETS. You can see, you remember we changed this. Okay, great. So for the push button, the C and T flag are on. Okay, because the push button is like the sensor. For weather module, weather sensor, also the T flag is on for all the data we have it, for temperature, wind, brightness, rain, quantity, and so on. Also in blind actuator, okay, for example for channel 1, for a status that is called in KNX virtual info position, the T flag is on because it wants to change, to send the latest information of the position of the controller of the shutter. Great. So now you feel something more about the T flag. So when we come to the T flag, the book provides us some example that shows the a specific situation, and the book wants us to not make a mistake. So let's go to study that. The topic of this example is a specific transmit flag configuration can trigger telegram chain reactions. It means maybe you face the chain reaction if the flags are set in the wrong way. In the example, two dimming actuators are switched in parallel. Okay, the transmit flag has been set for both dimming actuator at the combined switch status object. Remember that nowadays the switch actuators always the group object for control and group object for status is different. Okay, if for example you have the dimmer actuator, the phase dimmer actuator, we have one group object to switch on off the dimmer, the relay actuator in a dimmer actuator, and we have one status switch on off. Okay, so the flag for the actuator is C and W, and the flag for status is C and T. But maybe in some situation, probably the old dimming actuators, we have one switch, one group object to switch and status. Okay, so in this case, or we can say in this configuration, if you want to control both of the two channel, for example channel 1 and channel 2 of the dim actuator, and you put two group objects that in each group object the T flag is on and also the W flag is on, we face a problem. This results in both actuators sending a telegram, for example, to the destination group address 101 in this example after each update of the switch status. The other actuator receives the telegram and sends an update telegram. Result of such a situation is chain reaction of update telegrams. The bus is put under the heavy load and the actuator possibly no longer reacts. Okay. What it means? It means because it sends the new value, send it, we have W, write it, then T, send it, we have W, write it, then T, send it. Okay, so we will be in a wrong chain reaction. But as I said today, these days, the new actuators, hopefully, we have the different group objects for switch and status, and the flags are set in a correct way by the manufacturers. But maybe in some situations we face these problems and we should make aware about it. Great example, thanks KNX book. The next flag is R flag, or we can say the read flag. The read flag enables the object value to be read out via the read telegram. So there is the sense of status from the actuator side. This function is required for visualization, light scenes and etc. to query the current object status. If we want to get deep into it, we can say if the read flag is set at an object, the bus devices responds to a read request telegram with the response telegram to the sending group addresses of the object. If the read flag is deleted, there is no response. The read flag is not set by the default in most cases, but the read flag is set by many manufacturers for a status object. For example, in ETS, for example, if we have the power supply with diagnostics, and we have the status measured value. For this measured value, you can see the communication flag and the R flag and the T flag is on. So the T flag is on, any new value will be sent on a bus, and the R flag is on. So if we place this group object into the group addresses, it will be response to the read request from the monitoring side, okay, or from the controller side. So as the book said, for most of the status group objects from the actuators or similar applications, in addition to the C flag and probably T flag, the R flag is also on. For example, you connect your switch actuator to the visualization, okay? So the source address of the visualization, it can be USB interface or IP interface, is 11255, okay? Then the destination of the status is 321. So the status of the switch actuator are set in a group address 321 with the read flag. So the telegram of the read request is sent to the 321, and the switch actuator from the source address 111 is sends the latest status to the 321, okay, as a response. It will be said the relay is closed or open. It will be said if the lamp is on or off, okay. So this is the sequence of the read request in KNX devices. In addition to what we said, the book provides us a special feature of a read flag. Some specific features should be noted when using the read flag. First of all, the read flag should only be set at the bus device which is to respond. Okay? So the actuator wants to respond. The power supply with diagnosis wants to respond. And similars. The next important note is the read flag is only set once for each group address. It's very important. In one group address, okay, you have several group objects, but only one of them should be set with read flag. You never ever have two group objects with the read flag on in one group address. Remember that. Great. So next point is if the read flag has been set for a group address at several objects, a read request would trigger several response telegrams. Different status values could be answered shortly after each other. The effects on a reading device would then be hard to predict. So this is something to support the last point. In one group address, only one group object is with read flag on. If you have several group addresses with read flag on, you will face the problem because there will be different responses from those group objects, and at the end you never have the right status information from that group address. The group address that is used to read out the object status must be placed at the transmission point of the bus device that should be read out, as the sending group address is only used as a destination in the response telegram. Great. Always remember that this S which provide us a sending should be on when you use the group object with the read flag. You can see here the status info position from the blind actuator. This S that shows us in below the sending column should be on always. If it's off, so the group object never sends its value, never respond. So about the update flag. The update flag adopts a special role. It controls whether the received response telegram should be ignored or whether received value should be transferred to the group object. If the update flag is set on, a response telegram of a read procedure is interpreted as a normal write telegram. It means the value of group object is changed by the response telegram. Great. If it is deleted, response telegram are ignored. Update flag can only be deleted from the system 2 bus couplers onward. So we cannot change it for system 1 from system 2, 7 and B. In the case of system 1 bus coupler, the update flag is always set. Devices with bus coupling unit 1 do not distinguish between response telegram and normal write telegram. They therefore change their object status as a result of read response sequences. It's related to very old system 1, of course. So let's go for example of interaction of read and update flag. Here we have the central light with a group address 001, the light living room 101, and the light staircase 112. So here what's happening? Because the U flag is on and the U flag in response, it interprets the read response as a write, so it will provide us some problem. Listen. First of all, we press the push button. Multi-push button sends a telegram to 112. 112 is a destination address to the light on-off for the light staircase. Okay, great. So you can see the 112 here. The channel A is linked to it. And the actuator 132, okay, sends a response telegram to a sending group address 001. This 001 is a central group address you can see here for all on-off central function. With useful data on or off, all other bus devices listen to the response telegram. So all objects which the update flag is set, like the group objects of switch channel A, okay, or the group objects of switch of universal dimmer with the U flag on, and which carry the address 001, and all of them with the group address 001 as a destination, now interpret the response telegram precisely as a normal write telegram and adopt the useful data is on and off. The relevant actuator channels are switched. So what it means we should take care of the U flag, okay? If the configuration is incorrect, read request can trigger unintentional switching action, okay? Because the read request is interpreted as the write with the update flag as on. Okay, the next one is the read on initiate flag, the I flag. In addition to the flag that we already talked about it, System B devices, the latest one with the mask version 07B0 and 17B0 will also offer a read on initiate flag called I flag. If the read on initiate flag is set for one or more group objects, the device automatically triggers read flags to the sending group addresses after bus voltage failure or recovery. It means it concerns about initialization. The I flag is not set by default in most cases. Usually a delay can be set in parameters for triggering read flags. If many I flags are set in an installation, the delay for all relevant devices should be set carefully and of varying duration. Otherwise, it could cause a high bus load if a large number of devices sends their read request simultaneously after bus voltage recovery. Okay? So all the things about the I flag is for initialization, and you should make sure that for initialization for many products in the same system, same line, at the return of the bus failure, if you do not take care about the delay, you will face the problem. Because when the read on initial flag is on, when the bus is coming back, the read request is sending to get response from the all status of the actuators to update the monitoring systems and so on. Great. Thank you so much for listening to this course. We already finalized this chapter. I hope you enjoyed. Please let me know if you have any questions through the email or WhatsApp. Have a nice day. Thank you. Bye-bye.